All right, section 6.7. This is the last section in chapter 6. This is just a couple of applications of the definite integral to business and economics. We're not going to be getting like too deep into any of this, but I did want to introduce you to some of the basic concepts here, which are producer surplus and consumer surplus, and hope that you get at least just a baseline understanding of what each of these represents. You might see it later on in your business and economic lives, although I don't know that you'll see it in another math class here at ECC, but it's something that you could definitely look at down the road, again, in maybe a business or econ class. So the objectives here are we're going to solve problems involving consumers and producers surplus. So kind of recalling what we had talked about supply and demand. I know it seems like so long ago. I think we first introduced supply and demand in chapter 2, so it's been a while. But for demand functions, we're going to think about this from the perspective of demander. From the perspective of the demander or consumer. The person who's spending money on something is the consumer. Now, if the price goes up, the demand is going to go down. People are not going to decide it's something that they need to have or want if the price is going to be up so high that it just doesn't make sense for them to purchase it. Now, when the price goes down, the demand will go up because it's more affordable. More people will want that item. So that's the whole idea for the demand. And you can see this demand function here, d of x, is usually the way that we would label that as it was introduced in previous chapters. Now, suppose that we've given market price, and by the way, I'm going to be adding bars to all of these. The bars are not in your notes, but we're going to be talking today about units P bar and X bar. So P bar is a given market price, and I'm just going to put bars on top of the P's, and this corresponds to X bar units. So that's going to get a bar on it. So again, and there's actually a little bit more of a deep dive in your textbook of this, but basically it's just saying that X bar units just corresponds to a given market price P bar. Okay, now the difference between what the consumer is willing to pay for X bar units and what they actually pay, the set price, P bar, dollars, is called the consumer surplus. So this is basically, you're taking your demand equation, you're looking at this curve, and you've got some Y value, P bar, that's going to correspond to an X bar value. So the number of units that corresponds to that set market price. And again, your text has sort of a deep dive into all the little rectangles and all the ways that you come up with the sums here. But this is just, the value for Y, which is that set market price, P bar. Now, the function that you're going to use here to find that consumer surplus, CS is what we're going to call it. When you see it again, you'll know. You're going to integrate from 0 to X bar. And inside the integral, you're taking that demand curve and you're taking away P bar dx. This can also be written as the integral from 0 to X bar of your demand curve, d of x dx, minus P bar X bar. So this is just that quantity where if you're going to be integrating this with respect to X, this is a constant value. So that is just going to get an X plopped onto it. It's going to be P bar X. It's going to be evaluated from 0 to X bar, which is where this comes from. So you can use either one of these when needed. I don't know. Do I need to formalize what I just said? Sure, why not? It wouldn't hurt. So you're basically just looking at d of x from 0 to X bar, and then when you take off that constant value, you integrate that as P bar X from 0 to X bar. And that's where you end up getting P bar, X bar. Here. All right, so that's what you're going to be using for the consumer surplus function. You're going to be asked questions about a consumer surplus when given a value for P bar and a number of units that correspond to that. So if you're asked for consumer surplus, we're going to be using this formula and integrating over this quantity. The other one that we're going to be talking about today is it regards the supply function and the producer surplus. So for the supply function, you can see its curve. All right, so the supply, it's kind of important that we think about this from the perspective of the supplier. Think about this from the supplier's perspective. In this case, if the price goes up, then the number of supplied items tends to go up. If a company knows that they're going to be making a lot of money off something, then they're going to make more of it so people can buy it. If the price goes down, they're not making as much money off of it, and they're probably going to make fewer of the item because it's not a big ticket item for them. So that's kind of the idea here on your supply function. Again, something similar here with the X bar and the P bar. In this case, the market price P bar is the same as it was in the previous consumer surplus definition, and X bar units is just the number of units that corresponds to that market price. The difference between what the producers actually get for X bar units and what they would have been willing to get is called the producer surplus. Don't forget your P bar. And then I'll give you these two correspond to each other, X bar, P bar, where Y is just a value of P bar. So the equation here is kind of similar to what we saw before. This time you're going from 0 to X bar, and you're taking P bar minus your supply curve function. And again, if you integrate this, it's a constant. You integrate it with respect to X, and you use the FTC, you're going to get P bar X bar. So you're going to get P bar X bar minus the integral from 0 to X bar of S of X dx. S of X, a hard one to say. So that's kind of the big idea here. The producer surplus is the difference between what the producers actually get and what they would have been willing to get. And the consumer surplus is the difference between what they actually paid and what they would have been willing to pay. The idea here behind the two of these and using these curves together is on the next page. Now, recall that when working with the supply and demand curves, that often the price settles at an equilibrium point. So this is important here, where the quantity, and the quantity, of course, is going to be the equilibrium quantity. We kind of talked a little bit about finding equilibrium quantity in a prior chapter, whether it was 2 or 3, I can't remember, but I want to say it was 2. It settles at equilibrium point where the equilibrium quantity and the price kind of match up graphically. So this is where we're settling at this point where the equilibrium quantity is equal to the equilibrium price. So you can see that represented on the graph. This point would correspond to the number of units, X bar. And then on the graph, corresponding on the Y-axis, we have this value of E bar. Okay, so you're seeing here these two curves. You've got your supply curve heading up, you've got your demand curve heading down, and the intersection point of these two curves represent this equilibrium point, X bar, P bar. And here you can see sort of like the area underneath these curves and this line that sort of represents this horizontal distance here at the height P bar over here to X. You've got the consumer surplus above and the producer surplus below. So kind of depending on where you are, how many units you've produced, kind of depends on which situation you have regarding the consumer or the producer surplus. If you move to the right, that's going to switch again, kind of depending on how many units you have. Okay. So that's sort of background between this. It's helpful to have some sort of a sense of what you're doing before you answer these questions. Let me give you an example here. You can kind of see how you're going to work with these. We're going to let P equal 60 minus x squared over 10. This is going to become your d of x, your demand curve, where x is in units of hundreds. So we're going to have to remember this at the end. Don't forget it. So this is going to be your demand equation. Suppose the price is set at $40. So $40 in this case would be your P bar. What is the consumer surplus? Remember, this demand equation is created by a bunch of mathematicians at the company who put all this data together, and they end up having a function for the demand based on the number of units sold. So you're being given, in this case, a demand function that this company already has in place that follows the sales of this item. The demand equation represents x in units of hundreds. The price is set at P bar equals 40. So you're being asked to find the consumer surplus. In order to do that, I'm going to remind you of this equation we found on the previous page that I gave you. The consumer surplus is going to be the integral from 0 to x bar of d of x minus P bar dx. I'm going to rewrite that here because we are going to use it. So consumer's surplus is equal to the integral from 0 to x bar, and then d of x minus P bar dx. Okay. Now, we have some of this information. I gave you d of x, the demand function, and I gave you P bar. What you don't have right now is x bar. So you're being asked to integrate from 0 to x bar, that quantity, but you don't actually have the quantity at this point. So what you're going to need to do is use this price P in order to find the quantity x that corresponds to that price. So we'll do this off to the side. So if we know that the price at this point is going to be $40, we can set that equal to the demand equation to solve for x, which is that quantity that corresponds to that price. I'm going to rewrite this as 1/10 x squared just to make it a little bit easier for me to solve this equation. Kind of do this however you'd like. I'm going to subtract on both sides. I'll get negative 20 equals negative 1/10 x squared. Multiply both sides by negative 10. And I'll get x squared equals 200. I'm going to take the square root of both sides. Normally, when I take the square root of both sides, I need to apply a plus or minus. But in this case, I can't have a quantity supplied negative. So I'm not going to worry about the negative variation of this. I'm going to say x is the square root of 200. I'm going to simplify that because I know that 200 is 100 times 2, and 100 is a perfect square. I can take the square root of 100 as 10, and then I have 10 root 2. So this is that quantity x that corresponds to this. Since we found it, we'll call it x bar. That corresponds to P bar. All right, so now we have everything we need here to integrate this quantity. So let's go ahead, put this together. together into the integral. I'm taking the integral from 0 to our x bar, which is 10 times the square root of 2. And we're going to take the demand function, which is 60 minus, again, I'm writing this as 1/10 x squared because I feel like it's going to be easier for me to see when I integrate it, and then minus p bar, so which is minus $40 dx. Now, yes, technically we could just take this out and apply the x to it, but it's going to be easier just to combine these two constants together. So I'm going to do that instead of just using the alternate version of the formula from the previous page. So 60 minus 40 is 20. And now we'll integrate this function to find x. All right, so I have 20x minus 1 over 30 x cubed, and we're going to take that from 0 to 10 root 2. Okay, so let's use the FTC now to evaluate the definite integral. So I have 20 times 10 root 2 minus, oh, I need my parenthesis there, 1/30, and then 10 root 2 cubed. I kind of want to just multiply this out 3 times because I feel like it's going to make the math a lot easier. So instead of using that cube notation, I'm just going to cube it by multiplying it out. And then, of course, my lower limit is going to be 0. I didn't forget about it. It's just not going to really matter to me in this case. Okay, let's go ahead and find this value. 10 times 20 is 200. And then I still have that square root of 2. 10 times 10 is 100. Times 10 is 1,000. And then I'm going to divide that by 30. We'll simplify this in a second. We can always get rid of a factor of 10 there. The square root of 2 times the square root of 2 times the square root of 2 is the square root of 8. But the square root of 2 times itself is 2. And then I still have this 1 square root of 2 left over. 200 root 2 minus, I'm going to get rid of a factor of 10s here. So this is 100 thirds. I should say 200 thirds if I multiply it by 10 times the square root of 2. And you can sort of think about this as like you're combining like terms. I'm just going to take 200 and then subtract off 200 thirds. Math, enter, enter. I get 400 thirds root 2. And of course, we don't want to leave our answer like this because it does not mean anything to us. Remember that what we're looking for here is the consumer surplus, which is a dollar amount. So I'm going to go ahead and write my 400 thirds and multiply it by the square root of 2. And then this gives me 188.5618. If you're like, why did she leave 4 decimals if we're talking about a price? That's because remember that you were given X in units of hundreds. I made a big deal about it at the time, and we need to go back to it. So once you find that value of X, this is in hundreds. So you're going to multiply it by 100. When you multiply by 100, you're just taking this value times 100, and you get $18,856.18 approximately. So this is just moving over 188.5618 decimal comma $18,856.18. Okay, so this is that consumer surplus value that you're looking for here that corresponds to a price of $40, and our X bar is 10 root 2. That's the number of units. Okay. Now, do one more of these. I only have 2 examples here. We're really ending this chapter on like not a ton of examples, but I feel like that always happens as you move to the end of a chapter. You get into these more granular topics, and there's just not as much to say about them. Did I say everything there? Yeah, I think I said everything. Okay, last one. Then you can be on your merry way. Ooh. No. Sorry, I'm having like issues with me. Okay, there we go. All right, last one. We are going to let P equal 60 minus 1/10 x squared be a demand equation. And let P equals 30 plus 1/5 x squared be a supply equation. Both in units of hundreds. Find the producer surplus at the equilibrium point. You spent a lot of time talking about how to find equilibriums back in whatever it was. I should figure this out. Was it chapter 2 or 3? At some point you saw this previously and you were looking at demand and supply equations and finding equilibrium points. So let's do that now. The way that we're going to find the equilibrium is just by setting these two equal to each other, and then we'll find the value of x that makes the price for both of these the same. So I'm going to say 60 minus 1/10 x squared equals 30 plus 1/5 x squared. And we're going to solve this equation. It kind of does not matter if you want to set this equal to 0 or how you want to do this. If you want to just start out by saying, I don't know, let's add 1/10 x squared to both sides, that's fine. I don't know why this dot is here. Use the whiteout that's at my disposal to remove it. And what this leaves me with is 60 equals 30. And then 1/5 is 2/10 plus 1/10 is 3/10 x squared. So we have that. Okay. And then you can go ahead and, if you would like, move the 30 over to the other side. Subtract 30 from both sides, and you'll get 30 equals 3/10 x squared. Multiply both sides by 10/3. And set that equal to x squared. If you're wondering why didn't she set this equation equal to 0, it's because I didn't have a linear term here. I just had constants and then quadratic terms. So if I had a linear term, then yes, absolutely, that's what I would have done. So I have x squared equals, when I cancel here, I'll get 10 times 10 is 100. And then x equals the square root of 100 is 10. Remember, I don't want, in this case, to have a plus or minus. So in this case, I just left it as 10. Positive 10. Wonderful. That's going to be the value of x bar. We're going to need that to find the producer surplus. So remember, I asked you to find the producer surplus at the equilibrium point. The equilibrium occurs for x bar equals 10. So let's go ahead and set up our integral. Oh, let me remind you what the producer surplus is. It is the integral from 0 to x bar of, and then you're taking p bar minus s of x dx. That was given to you on the first page. So now we'll go from 0 to 10 of p bar, which is, where is our p bar? Oh yeah. So this is actually the quantity. We should have found this first, but we did not. That's okay. We'll find it. Don't worry. Don't worry, she says. We need to find the p-bar that corresponds to this x. Got a little bit ahead of myself there. But you know what? That's actually not a bad thing, because if you got a little bit ahead of yourself as you were working on this, you'd be like, all right, yep, got it, x bars, you're at 10. And then you'd be like, hold on. We have the supply equation that we have. We're going to put that in there, but now I need p-bar. So I've got p-bar that I'm looking for, and I don't know what it is, but I know the supply equation is 30 plus 1/5 x squared. Dx. So we're going to have to find p-bar. Big deal. And then we can integrate once we find it. So I can go ahead and use either one of these original equations with the value of x that we found to find the value of p that corresponds to that x. You decide. It doesn't matter. It's going to be the same at both places because it's the equilibrium point. So it does not matter which one it is. So let's say we'll say that p-bar equals, and I don't know, pick which one you like better. Which one looks like it's easier to compute? If x is 10, I'd probably just use this one. I don't know, they're probably going to be about the same. 60 minus 1/10 times x bar squared, which is 100. So 60 minus 10, you get p-bar equals 50. Okay, so that was just by using this value in the demand equation. And that's the corresponding value of p-bar. Okay. Back to this. We're going from 0 to 10 of, now we have 50 minus 30 plus 1/5 x squared dx. And we will simplify and integrate. 50 minus 30 is 20. And don't forget to multiply in this negative sign. So it's minus 1/5 x squared dx. And then we'll integrate. 20x minus 1/15 x cubed. And that's going from 0 to 10. I'll use the FTC to simplify. 20 times 10 minus 1/15 times 10 cubed is 1,000. And when you take off the lower limit, you're just taking off 0 in that case. So I'm going to be taking 20 times 10 minus 1,000 divided by 15. And that gives me, remember I'm looking for a dollar amount here, 133.33, and this is in hundreds. Because that was given to you in the beginning, hundreds. So if that's the amount you found in hundreds, multiply by 100, and then you'll get your dollar amount to be 33. You just had a bunch of threes after that. $13,333.33. So I don't know. I know this section's kind of weird because it's concepts that you've probably never seen before, but you're really just using the same math that you've been doing this whole chapter. So it's just figuring out exactly how to apply it to the problem. But it should be pretty clear when you're working on these problems which function you're dealing with, whether it's supply or demand. And if it says equilibrium, you're just solving that system of equations to find that point. So I don't think you'll have too much trouble here. That's it for chapter 6. I hope that you have a wonderful rest of your day. Bye.